Hello guys, do you know that this question came out in WAEC 2017 as question number 15. According to the question, he said the energy stored in a spring of stiffness constant 2000 Newton per meter when extended by 4 centimeter is worth. Now, when you look at this question, the first thing that should come to your mind is a topic in physics called elasticity. Yes, the question was gotten from a topic in physics called elasticity. Take note of that. Now, in elasticity, you can be told to calculate for the energy stored in a spring. Yes, they can ask you to calculate for energy in a spring, or they can ask you to calculate for work done in a spring, or the work done by the spring. So when you are told to calculate for the energy in a spring, sometimes they can put string. Yes, they can put string, or you are told to calculate for the work done in a string. There are 3 formulas that you must deploy. 3 formulas. What are the formulas? Formula number 1, the energy is equals to 1/2 Ke squared. Yes, I said that. That's the first formula for the energy or the work done in a spring or string. Formula number 2, the energy or the work done is 1/2 Fe. Please take note of this. Formula number 3, the energy or the work done is equals to F squared over 2K. Yes. So basically 3 formulas used to solve questions in elastic spring. Now, what do they stand for? Your K is called elastic, please take note, or force constant. Yes, K is elastic or force constant, and the unit is Newton per meter. So we have to be consistent with our unit. E is known as the extension produced. This extension sometimes can be called compression if the spring compresses. Take note. And your extension is the final length minus the initial length when it is increased, or the initial length minus the final length when it is decreased. Now, finally, your F is the force applied. Your force applied must be in what? In Newton. Then, like I said, K is your elastic or force constant. Your K is also called stiffness constant, or better still, call it stiffness. Yes, that's the ability for a material to retain extension, or sorry, to resist extension. So if you look at the question, it says that the energy stored in a spring of stiffness constant, this is our value for K. Please take note. When extended by 4 cm is what? First of all, our K, which is known as our stiffness constant, they said it is equals to what? 2000 Newton per meter. Are we together? Now, your extension is 4 cm. Please, we have to be consistent with units. If you are given extension in centimeter, divide it by 100 to get your value in meter. If you are given in millimeter, divide it by 1000 to get the equivalent values in meter. Take note of that. So this one was given to us in centimeter. So we divide it by 100 to give us 0.04 weight in a meter. So listen, I said there are 3 formulas used to store for energy stored in a spring. The formula is 1, 2, 3. Are we together? K is your constant, F is your force, E is your extension. And that's what you have here. So if you look at this one now, they gave us K and E. We'll look for the formula here that will help us to solve the question. So according to this question now, we will use formula number 1 because it contains K and E. So if I deploy my formula 1, energy is 1 over 2 KE squared. So therefore, the energy will be equals to what? 1 over 2 times K is what? 2000 times 0.04 squared. So 2 cancel 2000, you have 1000 times 0.04 times 0.04. So what would that give us? Let's do that quickly. 1000 times 0.04 multiplied by 0.04. You have 1.6 joules. This is your answer. So your answer is not A, your answer is B. Now please solve this question for me. NECO 2009, question number 53, using any of this formula. Thank you very much. I'll see you in my next video. Don't forget to subscribe.